Victor, what type of function is this? Quadratic. You got that right. Hopefully you did. What type of shape is a quadratic in? What's the shape called? Yeah, parabola. Angel, what's the vertex? Beautiful. -1, 8. So remember, your vertex is the very tippy top or tippy bottom. In that case, it's the top. Allison, what's your axis of symmetry? That's your roots. What's your axis of symmetry? You know that's one. Yeah, it's your x coordinate, your vertex. So axis of symmetry is x equals -1. And now, Allison, what's our roots? Beautiful. So remember, roots, zeros, x-intercepts, they're all right there. Cool. Tristan, what's our y-intercept? Beautiful. 0, 6. Keandra, what's our domain? Yeah. -infinity to +infinity. Perfect. And then for Tiana, do you know our range? Were you able to get that one? No? Does anyone have the range? Or want to give it a try? Remember, it's bottom up. So if it goes down forever and ever, what's that called? -infinity. And then what's the highest point it goes to? What's the highest y? Yep. So it's -infinity to 8. And it's a bracket because it touches it. Cool. Rate of change between -3 and -1. So this is all part of our lesson. So make sure you're paying attention because basically that's not much of a lesson. It's more of just practicing this ticket in the door. So rate of change. Victor, what are the 2 points that I'm looking for? If it's looking for an interval between -3 and -1, what points would that be on the graph? So it would be -3. What coordinate is that? Good. -3 and 0. So when it's an interval, remember these are your x coordinates. And then -1, what's your y coordinate? Not 0. -1. I'm just looking at 1. What's your y coordinate in -1? Yep. 8. So it's these 2 points. So when it's an interval, remember, those just are your x coordinates. Then we find our rate of change, which means our slope. So remember, we label x1, y1, x2, y2, and then we plug it into the slope formula. So 8 minus 0 over -1 minus -3. What is 8 minus 0? And then -1 minus -3. What will that end up being? If you need a calculator, you can. So we end up getting 2. What's 8 divided by 2? 4. So your rate of change right there would be 4. Make sure you're also writing this down, because remember, part of your quiz grade is literally just writing down the correct answers. Awesome. Any questions on that one? What? If you guys need a calculator, they're in that blue basket back there. So you can go get one. Carlos, is this leading coefficient going to be positive or negative? Looking at the graph. Good. How do you know that? Beautiful. Because we can see it's like a negative Nancy, so it's going to be going down. So our leading coefficient will be negative. Cool. End behavior, who can tell me what that one would be? That says as x approaches infinity, so remember a lot of us had trouble with this. As x approaches infinity, that means I'm looking as the x's get bigger. So when I'm looking as the x's get bigger, what's happening with your y values? Are they going up or down? What about this one, when it gets towards negative infinity? What's happening with the y's? Are they going up or down? Down. See how both arrows are pointing down? So that means my end behavior for both of them is going to be negative. So basically, end behaviors is basically where the function ends. What direction is it going in? Does that make sense? All right, circle how you feel. A lot of us, characteristics is our kind of hardest lesson. Some of us, it's our easiest. It just depends what type of learner you are. So what we're going to be doing today is literally this. We're comparing quadratic, linear, exponential functions, their characteristics. So you're going to go to your practice for today, which looks like this. And so they give you 3 different functions. And so we're going to be going through each of them and how will we find them. So basically, let's figure out first what type of function it is. So f of x is that dark blue one. Damon, what type of function is that dark blue one? Beautiful. Linear. How do you know that? What word's in linear? Line, right? So we know linear is a straight line. So that's why that one would be linear. Stephen, what would the green one be? The where's GeoX? The blue one, sorry. What would the blue one be right here? What type of function? Quadratic, right? So this one would be quadratic. It's a parabola. And then Carlos, what would that curved one be? Green one. What type of function? Yeah, exponential. Remember, exponential is a curve, quadratic is a parabola, and linear is a line. Awesome. Next, domain. Their arrows, domain means side to side, right? Their arrows are all going from one direction to the other direction. What's all their domains going to be? Keandra said it earlier, but she's not going to say it again. What's the domains going to be? Negative infinity to what? Beautiful. So all of these will be negative infinity to positive infinity because their arrows are going in both directions. Does that make sense? Now range is going to be a little bit different. Range is bottom up. Now let's look at the linear one first. If it's going down forever and ever and ever and going up forever and ever and ever, what's that linear's range going to be? Going down and up forever and ever. What's the linear's one's range going to be? Tristan, what do you think it would be? You don't know? Keandra, what about you? If it's going down forever and ever and up forever and ever. Yeah, negative infinity to positive infinity. This one still, the linear one is the same because it's just going up and down in both directions. The quadratic, we're looking bottom up. So when we look at the light blue and the quadratic, what's the smallest y value that it has? Right here, -5, and since it's touching it, it's going to be a bracket. So -5, so range is bottom up. So -5 is the smallest y value, but then it goes up forever and ever. So what's that called? Positive infinity. Does that make sense? The last one was exponential. And so we see what's the lowest y value it has. It's skewering off right here. Good. -3. It never actually touches it, so it's going to be a parentheses, but then it goes up forever and ever. So what's that? Good. So just make sure when you are doing range and domain that the smallest number goes first. We always do bottom up. Any questions on that one? You guys are going to be doing the next one on your own, so I want to make sure you guys have the example we're doing together. Asymptote. Only one of these. Who remembers what an asymptote is from exponential? I don't have to talk over the bottom. Asymptote. That word sounds like your rear end, right? So basically, it's where like the plane is ending. Which one looks like a plane ending? Or like where a plane is landing? It's light blue, dark blue, or the green? The green, right? So the green is the only one with an asymptote. So I'm just going to circle it, and the other ones I'm going to put an X. They don't have asymptotes. And the asymptote is just where the plane is landing. The plane is landing where your y equals what number? What's your y value right here? Where it's landing? Good, -3. So your asymptote, if you don't remember, is just where the plane's landing. I just remember it sounds like rear end, asymptote, where the plane's landing. All right, increasing. So let's look at this linear one. Is the linear one increasing or decreasing? From left to right. The dark blue one. Which one? What is it? It's decreasing. So I'm going to put a check on decreasing. I'm going to cross out increasing. What about the quadratic one? When I look right here, I can see from here all the way down to here. Is that decreasing or increasing? Decreasing. So it's decreasing up to when your x is 2, right? So when x is less than 2, it's decreasing. So I'm going to put that. When x is less than 2, it's decreasing. Then it goes on that vertex and bumps up, and then what happens with it? Increases, right? So when all the x's are greater than 2, when all the x's are greater than 2, it's increasing. Does that make sense? That's because a parabola goes up and down. And then let's look at the exponential one. Is that an exponential one increasing or decreasing? The green one. It's increasing. So we're just going to check off increase. One up, isn't it? So we'll check off increase. Cool. Now let's look at their end behavior, the linear one. And so end behavior is the ones that we get a little bit confused about. So first, remember, this is, see how these numbers are positive? They're always talking about x. So this is infinity. When they're talking about x approaching negative infinity, that would be this side. So the first one we're looking at is the linear one. As x approaches infinity, so as it goes this way, what's happening with this arrow? Is it going down or up? Down. So that first one, as x approaches infinity, I know it's going towards negative infinity down here. What about this way? What about when it goes towards negative infinity? What's happening with my arrow? It's increasing, so it's going up to infinity. So I would write that down so it looks like this. So when it's x towards infinity, it's going towards negative infinity. This one. Does that make sense? And behavior is just like where it ends. Cool. Next one is the quadratic. The quadratic is, are both arrows going up or down? Up. So both of these are going to be positive because they're both going up. The next one is talking about the first, we can see that it's increasing, right? It's going up. So we know as it goes towards infinity, the y is going to go towards infinity also. As the x goes towards negative infinity, it's going towards our asymptote. If you look on your graph on your sheet. So what's it going closer and closer to? What's that asymptote at? Negative 3. Does that make sense? I know it's a lot. Hopefully this isn't new information. This is just kind of reviewing what we've done in the past. All right, y-intercepts. It's just where it crosses the y-axis. So which one's the linearest y-intercept? What is that? Good, 0, 3. I'm just gonna write it right here so I don't keep going up and back. What about the quadratic? Where's that one? -1. And what about the exponential one? -2. Who has the highest y-intercept? Which function? Which one has the greatest y-intercept? The linear. So sometimes they're going to have you compare them. So that will be down there for y-intercepts. What's one similarity between them all? When you're looking at all these, what's one similarity that they all have? Anyone find it? No one can find one similarity, one thing they all three have. Thank you. They all have the same domain. So right here, we're going to skip the rate of change because we're going to do that next class. They all have the same domain. One difference, what's one thing that's different about all three? There's a lot of things different, but what's one thing? They all have different y-intercepts. They're all different functions. They all have different ranges. They all have different end behaviors. So any ones you want to write. Does anyone have any questions? This one is going to be what we're going to be doing over next class, so I'm going to have you guys do that next class. Cool. So you're going to go to your next page. And you are going to be handing this in for a classwork grade today. So what you're doing is you're looking at that graph and you're answering the same sort of questions. You can use your answers in front to help you, like if you forget what it means. But you are, like for your classwork grade today, you're going to that second sheet, which is like identical, it's just different graphs. And you're doing the same sort of thing. Does anyone have any questions like about any of the different characteristics that you don't understand? No? You're good? Okay. So we're going to give you the remainder of class to work on that. When you're finished, you can do your ticket out the door. Sound good? Yes, no?